Hi students, in this video we will uncover the most common mistakes students make while solving the questions from the lesson Electrochemistry. You know, it is one of the critical lesson in the CBSE board exam, right? And more importantly, we will be discussing about how to avoid such mistakes. Okay, let us start. First, we will be discussing the possible mistakes when students solve Nernst equation numericals. Okay, let us have a look. For different contexts, we will be using different forms of Nernst equation. Okay, if the question is about a half cell, we will be using this equation. If it is about a full cell, we will be using this equation. Half cell and full cell, how we can distinguish? Half cell means you will be having only one electrode. For full cell, you will be having two electrodes. For example, here zinc and copper, you will be having anode and cathode, like that. Then you can directly go for this equation. Here you will be having a single electrode, okay? Then you can use the equation of half cell. Mostly here, this equation you have to use for solving the questions about hydrogen. They will be asking to find the reduction potential of any metal. See, I am saying probably it should be hydrogen. Okay, hydrogen electrode at a different concentration. Okay, we know for hydrogen at standard concentration, what is the reduction potential? That is 0. Correct, right? This value for hydrogen is 0. And question is, you have to find the reduction potential at a different concentration. They will give the concentration, you will get what? The reduction potential. They can ask for any other metals, okay? They can ask for any other metals. At that time, this value will not be 0. Only for hydrogen, this value is 0. For other values, for other metals, the reduction potential, the standard reduction potential value, you will get from the table activity series, which will be given in the question. They will give the concentration, you can find the reduction potential. Now, for the equation of this type, AA plus BP gives CC plus DD. See, this equation you can use. Remember, this is reaction quotient. Concentration of C raised to C into concentration of D raised to D by concentration of A raised to A by concentration of B raised to B. This is for equilibrium. Remember, at equilibrium, E cell is equal to 0, not E0 cell. E cell is equal to 0. E cell is equal to 0. Keep it in your mind, okay? That is very, very important. Okay, E cell is equal to 0. Mistake number 1. Okay, see, using the wrong formula for E0 cell, we know what? E0 cell is equal to E0 cathode minus E0 anode. For doing this, first of all, we have to identify which one is cathode, which one is anode. Then only we can substitute the values properly. Otherwise, you will substitute in a wrong way. Correct, right? Now, how to identify which one is cathode and which one is anode? Okay, see, the easiest way is the one which have higher reduction potential will be cathode. Cathode always have the higher reduction potential and anode will be having less reduction potential. So when they give two reduction potential, the one which having higher reduction potential will be acting as cathode and the one which have lesser reduction potential will act as anode. So you can easily find what? E0 cell. See, most students know how to do this directly, but maybe few of you have confusion. That is why I explained this point here. Okay. Calculate the standard EMF for the cell. So you have to find E0 cell. If standard electrode potential for lead and zinc are minus 126 volt and minus 763 volt respectively. So reduction potential of lead is given. What is that? Minus 0.126 volt and zinc is also given. Okay. Now what is our task? We have to check which one is bigger. It is very clear that the reduction potential of lead is greater, so it acts as cathode. Reduction potential of zinc is lesser, it acts as anode. Now, how to find E0 cell? You remember, right? E0 cell is equal to E0 cathode minus 0.126 minus E0 anode. What is that? Minus 0.7663. So you can calculate and you will be getting a positive answer. So, hope you understand how to identify anode and cathode from reduction potential and how to find E0 cell. Okay. Second possible mistake is failing to correctly calculate n due to these two reasons. First one is ignoring the stoichiometric coefficient. See, we can go through this example. Okay, here you can find n from chromium or from H plus or from tin. Okay, so I am taking this tin as an example, okay, for explaining how to find n. Okay, now if you ignore the coefficient, what is the n value? See, 2 plus is becoming 4 plus. 2 plus becoming 4 plus means what? Losing of 2 electron, right? N is equal to 2. If you ignore coefficient, you will get n is equal to 2. Now check by considering the stoichiometric coefficient. 3 into 2, 6. 3 into 4, what is that? 12. 3 into 2, 6. 3 into 4, 12. So 6 become 12. Okay. 6 become 12 means n value is equal to 6, and this is the right value of n, and this is wrong. Remember, okay, this is the wrong value and this is the right value. Okay, you have to consider the stoichiometric coefficient. Same pattern you can find the n value from chromium or from hydrogen. Okay, you will be getting exactly same 6 only. Second possible reason for a wrong value of n is not balancing the half reaction before determining n. Okay, see, I will give you an example. Okay, listen. See, they have given cathode reaction, production is given, oxidation is given. Now, if you check here, how many electrons are there? You can see 5 electrons, right? 5 electrons here. Here only what? 1 electron. So what you do? Multiply this equation with 5. So what should be the new equation? 5Fe2 plus gives 5Fe3 plus 5 electron. See, 5 electron, 5 electron. So what is the n value? N value is equal to 5. Listen, when you multiply this equation with 5, don't multiply the E0 value with 5, okay? E0 value is constant. Don't multiply that value with 5. You will be getting some wrong answers. Remember it, okay? So this is how you can find the n value if the coefficient of electrons are different. Here you can see 5, here you can see 1. So you can use appropriate numbers for multiplying. Here I multiply the second equation with 5 and make the coefficient of electrons same. Both become 5, right? How to avoid mistakes in calculation of n? See, these are the two things you have to take care. Always balance the half reactions. Okay. Second is what? Check that the electrons lost in the oxidation is equal to electrons gained in the reduction. Okay. These are the 2 points you have to take care while calculating n. Next possible mistake is using incorrect powers or forgetting to apply the stoichiometric coefficient as powers for the concentration terms. Okay, we can try an example. You already see this equations, right? Okay, so here you can see cathode reaction is the, anode reaction is the number of electrons are different, right? So what you will have to do? Multiply this equation with 5, because here 5 electrons and here 1 electron. So multiply this equation with 5. So you will be getting what? 5Fe2 plus gives 5Fe3 plus 5 electron. Now see, assume this is equation number 2, this is equation number 1. To get overall reaction, what you have to do? Just add equation number 1 and 2, right? When you add equation number 1 and 2, you will get the overall reaction. By adding equation number 1 and 2, we will get the overall equation, we will get the overall reaction. Okay, overall reaction we are getting. Now after that, we are going to write the Nernst equation for the overall reaction. See, E cell is equal to E0 cell minus 0.0591 by n log. You remember reaction quotient, right? Product will be on the numerator and reactant will be on the denominator. Now for product terms, okay, the coefficient will be powers. Here 1, here 1. Now H2O is a special case. H2O, the concentration is 1. H2O concentration is 1, okay? So you can ignore. Now Fe coefficient is 5, it becomes power. Now reactant will be on the denominator. You can see MnO4 coefficient is 1, H plus coefficient is 8, it becomes power, right? Fe2 plus coefficient is 5, it becomes power. Okay, you understand how we are getting the powers Okay, that is from the coefficient. For that, you have to write the overall reaction appropriately. Otherwise, the power you're getting right, that should be wrong. Hope you understand. So, and identifying n and identifying powers in the Nernst equation is very, very important. Next mistake is incorrect rounding of values too early. So that what will happen? You will get inaccurate final answer. Okay, see, to avoid that, retain at least 3-4 values after decimal point. See, for normal question you can round off early, but for Nernst equation questions, okay, you can round off only on the final steps. That is very important. For understanding, I'll say an example. See, for example, this value, most of the students, what they will do? See, they will round off it as 0.06. So your answer will not be correct. So try to retain 3 to 4 decimal places in the intermediate steps, and on final steps you can round off. Okay. See, there are possible logarithm errors. Okay. For avoiding that, see, you have to know basic logarithm calculations, and definitely you must know these values. The value of log 2, the value of log 3 and log 5. And also you know, right, log 4 means what? Log 4 is 2 log 2. Okay, so log 2 value you already know from here. Now, basic calculations. For example, log AB is what? Log A plus log B. Log A by B is what? Log A minus log B. And also you must know log 10 raised to x. What is that? X. Okay, log 10 raised to x is x. Log AB is log A plus log B. Log A by B is what? Log A minus log B. Log 10 raised to x is what? X. These basic calculations you must know. These values you remember. In this video session, we discuss about the most common mistakes students make while doing the numericals of Nernst equation. Right? Now, as a continuation, we will be continuing this video session. Right? On the next video, we will be discussing about the other section of this lesson, electrochemistry. Okay. Thank you all.